So hello again from the Planets project to our training series. We are now already in the third date from our series on LCA trainings, and today we got life cycle costing on our agenda, and we have a very big team who is, as usual, in a very nice and cooperative way preparing these trainings jointly from different institutions from our project. Rina, so Laura is in the lead for today, and Lorenzo and Martina. And Loelia is also very active here from IPC. Thomas Heinekon, Teno, Carla, Ciensko, Ponima, Nagesh from Radboud University, Stephanie Desrousseau, CEA, Eva Hahn, Bakker, Beatrice, Alfaro Serrano from BNN, and myself from PLUS. And we are going to do now a training with you, a very interactive one on LCC, life cycle costing. So what do we see? We are going to be, after this introduction of myself, diving into what socioeconomic assessment is and what LCC is not, what LCC is defined on that. And then we are running again through this goal and scope and inventory and through these phases that we have already also seen in the other LCA trainings. Then we go interactive again. So we have prepared again a mural where we are splitting up in groups. And in these groups, we are going to be doing interactive, practical work together on a specific example. Yeah, and then we look into the results of what we have obtained in this interactive session and discuss a couple of issues that are relevant for LCC, including also critical raw materials. Yeah, and this will last for the next 1.5 hours, or maximum 2 hours. And hopefully, I guess you enjoy it. All right, so why do we do that? This is, of course, why we are, because we are having a project on different value chains, implementing SSbD, and one integral part of SSbD is life cycle analysis assessment. We have been previously performing trainings on scoping, for example, here indicated by this pie chart. And we are going to do also deliver some safety trainings on this dimension. But today we are going to look at environmental dimension. There, LCC is one of the methodologies required for conducting comprehensive LCA. Other parts is environmental LCA, which we have already looked at last time, a couple of weeks ago. And what's coming next then is social LCA as well. So this is our workflow here from our project. It's quite adherent to the SSbD framework. Here in the green, we have the scoping phase and then different types of assessments following the tiered model. Yeah, in effect, we need to combine then the different dimensions, safety assessment with sustainability assessment and functionality, of course, so that design basically novel products, alternatives. Where can you find more about this? As usual, I mentioned that there is a resource menu button in our webpage, and there you find training materials. They are all uploaded to YouTube channel and to Zenodo, so they will be eternally available, hopefully. And this is what we have there already, and the list is steadily growing. And you can access it via our resources or go directly and search Zenodo or YouTube channel. Yeah, and with this, just a very short mention on how this looks like. So, for example, this is one screenshot of the introduction that we did on overviewing the different methodologies of LCA and getting a little bit into this holistic view of what LCA needs to deliver, very relevant for SSbD, of course. What did we see so far? At the very first intro training, we were diving into this holistic thinking, life cycle thinking, where we were getting to know these different phases of LCA that we ran through also today and did also last time in the environmental LCA. We were having an interactive session on functional unit definition in practical breakout groups, also like what we are anticipating for today as well. We were talking about reference flow. The system boundaries were covered, and then did overviewing also these other methodologies, including LCC and social LCA. Last time in the environmental LCA training, we were kind of again diving into these kind of phases, as they are indicated here. reiterating a bit on the function unit and reference flow definitions. We looked into cradle to gate versus cradle to grave, cradle to cradle, like circularity, for example, then looked already in databases. We are also touching upon databases a bit today, of course. Impact assessment was then done basically in these practical sessions, looked at endpoints versus what are midpoints, what are endpoints, and then touched upon the important issues of data quality and sensitivity analysis. And we did some practical examples on paints, which we are also going to be coming back to the same example for the LCC today. And with this, I would like to give over to the experts training. So, Aurelia, I guess you take the next couple of slides.
Thank you, Martin. So here is a very quick introduction on why we perform the economic dimension in SSbD. So as you already know, we have strong assessments that are planned already in the safe dimension and also in the environmental dimension. And according to the SSbD framework, we should assess as much as possible integrated approaches. And among the available approaches to sustainability assessment, life cycle thinking is a really important thing here. And we want to have some life cycle based approaches to play a pivotal role in comparing the different options and solutions or alternatives in the scope of planets in terms of sustainability. And sustainability is divided into 3 pillars that are environment, social, and economic. And so we perform some life cycle assessment for the environmental pillar, social life cycle assessment for the social pillar, and life cycle costing for the economic pillar. And you can go to the next slide, please, Martin. So as I said, the sustainability includes 3 pillars, and the economic one includes life cycle costs that we will be discussing about today, and also the identification of critical raw materials that we'll discuss a little bit in the end of the training. And so, yes, we consider the 3 sustainability dimensions, as I already said, and the objectives of all of these is to raise awareness on the potential cost hotspots in the LCC part, and also the risks in the value chain in the CRM part, because we have on the CRM high demand on those materials, while we have supply that is limited. So this is why it is important to include in this economic dimension. And what is important to note also is that this socio-economic analysis is more suitable for comparative and relative evaluations rather than absolute assessments, because in the end of an LCC, you will know the overall cost of the whole life cycle of a product, for example, but that won't be as interesting as if you already have the life cycle costs of all of your alternatives that you can compare, and then you can choose wisely what the best option is. And this is all for the short introduction, and we will go to some question and a Menti session.
I hope you can see it already. And let's go on with the answers. So, most of you were right. The marketing expenses for commercialization are typically not included, while raw material costs are absolutely included. If you're doing life cycle costs for a product, you have to include them. Equipment cost might be hard to find, but you should include it because it is part of CAPEX. And it is quite important also to think about the personnel contribution, because it might be quite high in the overall cost for your functional unit. Then CAPEX and OPEX mean capital expenditures and operational expenditures. Capital expenditures are investment on assets like equipment, while operational expenditures are, let's say, recurrent costs, what you could think about day-to-day cost, for example. And in CAPEX, we have said we have to know the cost of equipment, but it is not enough. We also need to know the productivity of that equipment or of the plant in general and the equipment lifetime. And these two factors are needed because we have to calculate the cost of CAPEX, the cost contribution in the cost for the functional unit. So we have to find what fraction of the equipment cost can be attributed to the functional unit. And we will see more of this in the interactive session. On the contrary, personnel hours are needed to calculate personnel cost, and personnel cost is part of OPEX. And also maintenance is usually in OPEX because it is recurring, not an investment. Perfect. So we can go on, and I will leave the floor to Loelia for the first part of the introduction on life cycle cost.
Thank you, Laura. Okay, so now that you have a little bit of an idea of what is an LCC, we will go deeper into details. And so what exactly is LCC? So as we already saw a little bit in the Menti part, it summarizes all of the costs that will be associated to the life cycle of the product that you are developing, and that are covered by one or more of the actors or stakeholders involved in the product's life cycle. So what does this mean? It means that when you are performing an LCC, you need to take a point of view of one or many actors in the value chain to address what will be the life cycle cost for this actor. And what we include in the LCC is the initial cost. So let's say, for example, the investment on the machinery, the service cost, the preventive and maintenance cost, and also the operating cost. So the cost, for example, of the workers and the disposal cost in the end of life of your product. So this will include also the end of life of your machinery, for example. And what is not LCC on the opposite? So this is not a method for the financial accounting. It is more a method that will be used as an assessment, and that will be product related, and to compare different alternatives products. So yes, this is it. And you can go to the next slide. So as I said, the LCC considers the whole life cycle, but in the point of view of a specific stakeholder that will be chosen in the goal and scope phase that will be described later in the training. And you can go to the next one. And there are different possible uses of the LCC. So as I already said, it covers the whole life cycle, and it's the goal is to have the sum up of all of the costs of all of your life cycle stages for one product. And there is different possible use. So for example, the feasibility or economic sustainability studies, where you will measure the life cycle impact of a product or a process or a project on long-term budgets and operational results. Or you can also use it for the selection of raw materials or the sourcing of your raw materials. So there you would be comparing the life cycle costs by using different materials or suppliers. So this is where it is interesting to have a comparative assessment. But it would be also interesting to know whether one process is more interesting than another, or which kind of end of life would be more interesting than another. You can also define some trade-off. So for example, by identifying the design aspects that will most affect the life cycle. So Yeah, for example, it could be the energy consumption that is very high and that has a very high impact on your life cycle costs. It can be also used for the product or process development when you want to quantify the most impactful contributions. And this is where you want to highlight some hotspots on your life cycle to identify early on where it would be interesting to change some options, and also in sales strategies, where you would compare specific alternatives type of equipments. So, for example, based on the operational expenses and failure rates. So this is only a few examples of where it can be used, but there are, of course, many ones. And we can go to the next slide.
Yes, so now that we have seen the possible uses of lifecycle cost, let's have an example of what lifecycle cost is not in the context of safe and sustainable by design. So lifecycle cost is part of the old step 5 of the SSbD assessment, the socioeconomic part of the sustainability evaluations. And as we have said, the costs are related to the chemical or material or product that is assessed in the SSbD. So it is product related and it is in the SSbD assessment, which is different from having a cost evaluation of the whole SSbD assessment. This is what, for example, the SSbD-fied ECV calculator does. So that tool, we are citing it because it is Planet, and you probably have seen it in the webinars that have been published lately. It evaluates the economic feasibility and the cost for the company to perform the whole SSbD analysis. It is a cost evaluation on the whole analysis. It is not directly related to the specific product that is being developed and then produced. It assesses the return of investment of an R&D project or portfolio when the SSbD is included. And so while lifecycle cost is on the product, this tool, for example, is about the assessment and its competitiveness, and it helps tailoring the level of detail of the whole steps based on the economic feasibility. And so there is quite a difference between these two. So now I will hand over to Lorenzo to go on with the phases of life cycle cost.
Thank you, Laura. Okay, so now we can go, we can start with describing the phases that constitutes an LCC assessment. Basically, it follows the same phases of LCA. Therefore, we have the goal and scope, where we describe the reason for executing the study, and we define the functional unit, and then the system boundaries. Then we go through the lifecycle inventory, where we collect all costs over the life cycle of the product under investigation. And then we have the impact assessment, where we refer all costs to the functional unit. All phases interact with the interpretation phase that can help us to identify hotspot to further investigate. And this is also the basis to have an iterative assessment and a tiered assessment, which is also aligned with the SSbD framework, where we increase the level of detail of the analysis while executing the innovation stage. Going to the next slide, please. We can start by diving a little bit more in the goal and scope, which has all the elements of the LCA assessment. So as already said, we define the goal, the process flow and system boundaries, the functional unit, assumptions, limitations, the type of study, and the audience we expect the assessment will be read by. But in addition to all these elements, we have the stakeholder perspective, which is, let's say, new item to define in the goal and scope phase. And it's essential to be defined in the life cycle cost analysis. If we can go to the next slide, we can understand better why stakeholder perspective matters. As we know, in a value chain of a product, we have different actors that contribute to the development of the product. For example, we have the material supplier, the product manufacturer, the consumer, users, and the end-of-life actors that manage the disposal. And cost and revenues are relative to the stakeholders. The stakeholder we are interested in analyze in for which conducting the assessment. But if we can go in the next slide, cost and revenues are not only the exactly. So here we wanted to show how cost and revenues are relative. But this is not the only reason why stakeholder perspective matters. And if we can go to the next slide, please. The stakeholder selection also affect the system boundaries of the analysis, which is the perimeter we are considering. The cost to be included and the level of detail of cost to be collected in the inventory, the classification of costs versus revenues, as we said, and also the financial metrics to select to present in the impact assessment phase, as we will see later. Then it also shapes the interpretation phase and guides sensitivity and hotspot analysis. The take-home message is that different stakeholders have distinct priorities. Therefore, the LCC analysis must be tailored to their needs. In Planets, we will focus on the actors that are the chemical manufacturer, chemical processors, and product manufacturer. In the next slides, we will present a few examples of how stakeholder perspective affects the LCC analysis. For example, if we want to take the producer perspective, we would like to minimize the costs during the production phases. Often, the most impactful cost category in the production phase is driven by the raw materials. Therefore, a life cycle cost analysis might drive the choice of the most cost-effective materials to be used in the manufacturing process by comparing technical performances, their cost, but also their availability and also recyclability potential. And overall, also, of course, we need to account for all the manufacturing costs. Therefore, if we can go to the next slide, we have presented an example for a car body production where two materials have been selected to be analyzed, which are aluminum and steel. Here in the table, we have an example of a simplified life cycle inventory that will be described better later, where we have reported all costs related to raw material and the manufacturing process. For example, forming, stamping, joining, assembly, but also the labor costs and also the revenues that can be made from the recycling process. Overall, in this example, we can see that steel is the most effective choice from the producer's perspective. However, the design, the LCC could be also taken from the user perspective, as we will present in the next slide. For example, we would like to investigate the economic performance of the material within its operational lifetime, let's say, and the costs that are sustained by the users. In this case, we have presented two insulation materials. One is mineral wool, and one is a new insulation material, which has a higher initial investment cost, but over time, it has a lower, let's say, cost. And this means that after a period of 30 years, we reach a break-even point where where the new insulation materials becomes more cost-effective than the mineral wool, even though this one had a lower initial investment cost. Okay, now I will hand over to Laura again for the lifecycle inventory step.
Yes, so in lifecycle inventory, we collect all the data that is needed to perform the LCC. We need to list all costs connected to the product along the whole life cycle. That, of course, if our boundaries are cradle to grave, so from the manufacturing to the end of life. If they are less than that, for example, cradle to gate, which means only manufacturing, then of course it won't be the whole life cycle, but only the steps that we decide to include. We have to quantify all inputs and outputs in terms of cost to model the system. And these costs are generally divided into two great categories. One is operative costs, operational expenditures, which are the recurring costs, and they include the raw materials to produce the product, also the energy consumptions, the personnel, and also the operational maintenance of the equipment, for example, if it is relevant. And then there are investment costs, capital expenditures, which are the investment on assets. So they include the equipment that is bought or the plant that is built, and any other investment costs if they're relevant, like purchasing of land in some cases. And as we have said many times, the costs depend on the perspective and on the system boundaries. So to have some more detailed list of what we can include in an inventory, we surely need a process description and some general information and the block flow diagram. This is more connected to the goal and scope phase, but need to be collected from the relevant stakeholders. Then we also need to know the annual productivity and operative hours, because we, as I said in the Menti explanation, we need to start from let's say the plant values, but then we have to convert them to have a cost for the functional unit, and that is why we need the productivity. Then we need the personnel data, how many people, what salary, how many work hours they work for the specific process, because they might have to work in more than one process, but we are focusing on the one for the product we have to study. Of course, we need to know amount and cost of the input materials, of the energy flows, of the transport of the materials, if available. Then we need the cost of the equipment, but also their lifetime, because again, we have to convert it to the functional unit. If it is included, we can include the cost for the end-of-life processes of the manufacturing waste, and if we go to the end of life of the product, And then there are several other things that might be included if relevant. For example, if we include end of life and we know that the end of life has produces some secondary raw materials, and if we are the stakeholder that gets the revenues, then we can include them, for example. And finally, most important thing is that if you want to do a comparative life cycle cost, which means you want to compare your product with a traditional alternative, then you also need the data for the benchmark, the alternative. This is an example of what changes from an inventory for an environmental life cycle assessment and a life cycle cost. So suppose you are already collecting data for the environmental part, then you would have the square that you see on the left. You already have collected all the flows, but then you have to add the cost for all of the flows of raw materials, energy, water used as auxiliary, natural gas, waste. And you also have to add the personnel and equipment, which is typically, these are two flows, let's call them, that are typically not included in an inventory for an environmental LCA. We are still thinking about the manufacturer perspective in this example. And there are two things that should be noted. One is that if you are developing a product and you are currently at low technology readiness level, it might not be easy to have the CapEx, the equipment, also the maintenance and the personnel. It is unlikely that you already have real data. So you have two options. Either you exclude it or you have to do assumptions. We will see a bit more of that after the interactive session, but the idea is that assumptions can bring uncertainty, and probably the best idea could be to have an already scaled up process for which we have data, and you know that the process will be similar to the one for your new product, and you can probably assume the same data of the scaled up process. It would be a good idea, for example. And one other point is that costs are often confidential data, probably even more than flows amounts. And so this means that care should be taken when inventories are shared to prepare the life cycle cost analysis. So primary data is the best option. Primary data is everything that is site-specific and provided directly by the stakeholder involved in the product life cycle. This allows to have a very accurate life cycle cost and possibly less assumptions, which means that the results are more robust. But of course, secondary data may also be used, and sometimes it is necessary to use it. This means that you are using generic data that could come from databases, literature, or trade reports. To have an example, in Eurostat website, you can find data for the cost of electricity. So you just navigate the website and you can get some data divided by country, by semester of the year, and also depending on the power consumption of your industry. However, there is one thing that should be highlighted, and this is really true also for primary data, which is that cost values are highly time sensitive. It may be for inflation, but not only. So prices fluctuate significantly over time, which means that care should be taken when you collect the data, and also means that the result of the LCC have a time representativeness that is very, let's say, narrow. It is related to that period of time. Okay, so now we have had a quick introduction on the inventory for life cycle cost in general, and we can go to our interactive session, which will be divided in groups. So maybe Beatrice, you can explain a bit of the logistics, and then I will explain briefly what you will have to do in the groups. So the idea is that you already have a bit of an inventory in a table with some data, but there are no cost data, and you will have to add that cost data based on what you see in the yellow box. And after that, after you have everything in the table, there are some questions to be answered, like calculate total cost, calculate personnel cost, and some other questions. All data is referred to paint A, but maybe we can also do some qualitative considerations on paint B. And yes, that's it. And I think we can go to the rooms.
Yeah, welcome back. I guess we have obtained quite some results, right, in the breakouts. And we would like to run through quickly what was discussed, was maybe some important points. For that, I give over to Laura again, right?
Yes, exactly. I'm sharing just so you have under your eyes the one possible result. Of course, it depends on how many significant numbers you include in the values. But anyway, let's have some round on the groups. I'm group 1, but maybe I can go later. So group 2 was Lorenzo, right?
Yeah.
Yeah. What did you come up with? Any highlights?
I mean, we have some nice results. We obtained 3.256 euros per liter of paint, and 48% regarding the contribution of personnel on total cost. There were some discussion about the correct number to insert in the inventory for the personal costs, and we managed to get to the function, to the liter unit of paint, the labor cost to the unit of paint, and same for the equipment. We consider to spread all costs to along the life cycle, the lifetime of the equipment, to get also the cost to the functional unit. Thank you.
Okay, then Loelia, I think, was group 3.
Yes, so we didn't have time to finish all of the questions in the end because there was some questions that I think was not very clear about on the number of equipment needed for 1 liter of paint because we need, of course, one full high-speed dispenser, but then the impacts could be divided by the number of liters that are produced every year. And so it wasn't very clear, so we didn't go through the rest of the questions.
Also,
And
that's
maybe you can explain better than me because
Oh,
I
yes.
think I wasn't clear.
No, no, I think the point is the inventory, the cost part was not exhaustive, completely exhaustive, because there was no indication on the productivity of all the equipment items. You know that the paint, the whole process gives 120,000 liters per year, but what if your equipment can have a higher capacity, some of them, so maybe you also use them less, or maybe it's the opposite. So you have some equipment that has low capacity and you have to use two of them to buy double items. So that was not included, and it was also a bit meant to be discussed. But if you assume that the productivity is the same of the whole process, then you can take the cost of the equipment and divide it for the lifetime. So now you have the cost per year, and then if you divide it with the productivity, you convert to a cost per liter. And yes, that's it, really. So maybe we go to Thomas, and then I will add what in my group.
Yeah, we made some good progress with our calculations. I had some math geniuses that could calculate faster than I could even talk, so that went very fast. That was very nice. We had a very interesting discussion that I think is worth conveying here, is the idea of direct and indirect costs. All of the entries in the table seem to focus on direct costs, raw materials, labor, equipment, but a lot of the indirect costs, such as R&D or management, some of these things that you might think of as overheads, were not included. And some of the group made the comment that in some industries, such as pharmaceuticals, these indirect costs can be a larger contributor than any direct costs. We didn't come to any particular conclusion, but this was a topic of discussion.
True. So it really depends also on the productivity and the sector. Many times when you do life cycle costs, you just assume that the R&D costs are a negligible contributor. But of course, if you assume this, you have to have some knowledge of the fact that your R&D, when you convert it to the functional unit, can be negligible because you have a very high productivity. So it's not always like this. True. And anything else?
I don't think so. If anybody from my group wants to add anything, please feel free. But that was the main point of discussion. I would say.
Good. So I think I can add because we had a discussion on things not included in this inventory in our group, which was about maintenance. So we have no maintenance here, and it is not always easy to find maintenance cost. But what we came up with is also that maintenance can be somehow considered as a sort of category of cost, but then can be broken down. For example, you can have personnel cost for maintenance, and then maybe you also have it in your personnel cost, so it could be connected to that. You might have auxiliaries for maintenance, or maybe you have to pay it as a service. So it really depends also on what maintenance you're doing. One other thing is that we weren't very sure of what to put in the quantity column for the equipment, but I mean the conclusion is that it is really not that important after all in this case, unless you have two pieces of each equipment. Because in this inventory we were already converting to the cost per liter, so it becomes less important in a sense. But if you fill the inventory with the idea that those who do LCC will do all the calculations, that it will be filled differently than what we did now. And one thing we came out with is the qualitative question with paint A versus paint B. I don't know if you got there, but we know that the functionality is different because paint A needs 2 liters and B 3 liters, which means that the user will pay 10 euros for A and 15 for B, because we assume the price for consumer is 5 euros. But then there are also the other costs. So one is the number of brushes, for example, because paint B needs to be reapplied 5 years afterwards, after the first application. So maybe you have to buy another brush. But there's another one because here this is buying the paint and buying the brush. Okay, but that means you are assuming that you are doing the painting yourself, but maybe we are not. So you have to actually pay someone to do it, or pay someone, I don't know, to move the furniture. So it could be quite higher, the cost for user, even if you scale it for 1 square meter, which was a nice discussion. Yes, so I think we can move on. So we go, hopefully we will end at 12. A bit more things on what we already said. Personnel can have a high contribution. The data in the interactive session was invented, but it is true that it can have quite a contribution, and just changing from one adding one person is enough to have quite an increase, and it is not very easy to have a good assumption on it if you have a TRL product under study. And the other is again on CapEx and equipment. This is more relevant if you have a very low productivity, like custom pieces, very big pieces, which you have not only a low productivity but also quite expensive equipment. And one assumption that maybe doesn't seem important, but it is the equipment lifetime. In this example, you change by 3 years, and you just have a 25% increase in the capex. So it's not just it can be quite an influence if you have low productivity. If you have high productivity, sometimes the capex part is really quite negligible in the total cost of your product. Okay, so now I will hand over again to Lorenzo for the last steps of the LCA LCC methodology.
Thanks, Laura. As we saw in the interactive session, the objective is to convert inventory data to refer them to the functional unit. And in this phase is done in the life cycle impact assessment. We can get different indicators such as CAPEX, OPEX, and the sum of them or the total cost. However, other indicators can be used as in LCC results, but in SSbD they are not used or explicitly mentioned, and these can be the return of investment, the net present value or NPV, and the break-even point. Going to the next slide, we just show the formula to get the total cost per functional unit. And this is the exercise we have done in the interactive session. So we divide all the CAPEX by the lifetime of the plants, multiplied by the productivity, the annual production. Then we sum these to the labor cost divided by the productivity, and then we sum all the costs for raw materials, energy, electrical and thermic energy by the annual production. Finally, in the next slide, we present how results can be presented, some visualization, and here we want to stress the fact that as already said by Laura, economic data are highly confidential, and it can be preferred to show them as percentage. The breakdown of cost can be shown as percentage rather than absolute costs. We can go to the next slide, and I'll hand over again to Laura.
Yes, so as Luelia said at the beginning, there are some advantages points for including life cycle cost and also the critical raw materials assessment in SSbD, because of course it not only for considering all the pillars and raising awareness, but also because it can be a way to be ready for new regulatory requirements and also issues that the European Commission is interested in, like in the European Chemical Strategy for Sustainability or Critical Raw Materials Act. But there are also some drawbacks. First of all, you need some expert to do the analysis. The assessment becomes more complex because you add a dimension, which also means you have to consider it if you do trade-offs with the different assessment of SSbD. And then we have seen that there can be a low data availability and granularity both in secondary data and also in primary data, because if you have a low TRL product in the scale up, there are many changes that will happen, from the value chain choice to the cost estimates and also the scale up factors like yields of the chemical reactions. And one other factor of uncertainty is in the monetization factors that are used if you want to include the externalities in your cost. And I will explain a bit what it means, because it is included in the SSbD documents. So the idea for the SSbD LCC is that you start with a conventional SEC, as we have explained until now. But then you take the environmental impacts from life cycle assessment and you convert them to cost values using monetary valuation coefficients to do this conversion. And this cost can be added to the other costs, so that in theory you can also see the environmental impacts within your cost and use this to compare the design alternatives in SSbD. And this conversion of environmental cost is one method to somehow consider societal cost, which would be defined as costs that are borne by society and not by any specific actors in the life cycle of the product. The coefficients that are suggested in SSbD are the same as the ones in the eco-design of energy-related products, but there are some drawbacks. First, as you can see, some rows don't have a conversion factor, and this is because there is high uncertainty or lack of methodology for finding these factors to convert into costs. Then, of course, these factors also depend on the impact assessment method you use in LCA, because you need a factor for each impact category, and impact categories change depending on the method. But in general, there can be high uncertainty, and experts are not all in agreement, and there are several methods to calculate the factors, so these are all drawbacks. And finally, there is one more drawback we were also reflecting on in our project, which is connected to the overall SSbD score. So if in your SSbD analysis you also aim to have an overall score, which should merge all the dimensions or the assessment, it means that in this overall score you will have a contribution from lifecycle assessment, and then you will have a contribution from lifecycle cost. But if the impacts of lifecycle assessment are also inside the cost, then you risk double counting if you do the overall score. So to sum up, this monetization of externalities is a powerful tool if you do an assessment on cost only, because it allows you to include another aspect of the possible cost of your product. But it is not always trivial to include it. It could be better sometimes to avoid these factors. Okay, so now we have done all our introduction in life cycle cost, but we have still another step, the identification of critical raw materials, which is the other assessment that is suggested in the SSbD framework. First of all, what are these critical raw materials? They are 34 for now, according to the European Union list, which is updated periodically every 3 years. The latest is was published in 2023. They are crucial to Europe's economy and industries, but they face a high risk of supply disruptions. So there's high demand, and they are projected to have even higher demand in the future, but they may have a limited availability, and or they might come all from the same regions, maybe also regions with geopolitical risk of disruptions. They might also be in this list because they are critical and lack substitutes, so you can't substitute them in their technological applications. There is not a standardized methodology to assess them, and what is suggested in SSbD is that first of all you count the number of flags, which means you check if those materials are in your inputs for the product. This is a sort of flagging criterion. The other thing you can do is to check the mass of each CRM in your product compared to the total material input to see how relevant they are in mass. But then if you really want to go in deeper, you could also add a qualitative assessment of their supply chain vulnerability, because yes, maybe you have a high amount of a CRM, but maybe its supply chain is not as risky as another CRM that maybe you have in lower quantity but is more critical. So that's also something else you can check. So all in all, the idea is that if you have multiple flags, so many critical raw materials, or you have a high CRM content, then it might be that your product is lower in sustainability. So the goal of all this is to reduce strategic and sustainability risks that are due to supply insecurity and geopolitical dependencies, and also encourage innovation towards CRM substitution or minimization. But it is not an absolute cutoff. It is a driver, so if you have this check in the design of your products and you have more alternatives, you might want to go towards the one with lower CRM, but not necessarily. And we have one typical example, which is phosphorus-containing flame retardants. This is an example of a case in which, yes, you have a CRM, but is it really so important to choose the one without the critical raw materials inside? And this is why you need to more to add some considerations, because if you consider the whole supply chain of phosphorus and the demand, the flame retardant sector is surely not driving the use of phosphorus, because several sectors have much higher contributions to the demand. But still, one consideration that is worth keeping in mind is that the supply is limited. And so if other sectors increase their demand, the price could increase, and which means you would have a consequence anyway. So it's not a showstopper, especially in early SSbD assessments, but it is flagged, and you can keep it in mind for the next steps. That's all that there is. So good. I think we can go to the conclusions of this training, and I will hand over again to Martin.
Yeah, thank you, Laura. Please just continue sharing. It's
Yes.
fine like that. Yeah, let's quickly wrap up what we have seen today. First of all, let me thank Laura and team, Lorenzo, of course, and also Martina were contributing from Rina, Loelia, and so Thomas for leading the breakout sessions, Beatrice for organizing all these Menti and mural things. I guess we learned what LCC is, what also it is confined to, and what goes beyond LCC, what eventually additional aspects may be. We have looked into, and I've meanwhile now, I guess, understood what CapEx, OpEx is. We looked a little bit into critical raw materials. Then in the end, we were comparing LCC inventories to LCA inventories, worked ourselves through this interactive exercise. In the end, also we're having interesting discussions on from this cost inventory building exercise on what its direct costs are and what total cost would also include this additional indirect cost could be quite different from sectors to sectors. Pros and cons of LCC within SSbD were mentioned, and Laura was also alluding to the monetization of externalities, very important point as well. And finally, we did talk about critical raw materials, a very important aspect. So I would say these were the most important issues of today. What's coming next on the next slide? There are a number of further training events that we can announce already at this stage. So in the new year, we're going to have then our social LCA training on the 16th of January. We will then wrap up this series with an MCDA session to be expected sometime maybe in April, when we are also having our exercises being done within our Planets project. So this is will be very guided by the application in our case studies. Right, so with that, I would like to conclude. Finally, on the next slide, if there are any further comments, questions, concerns, we can still spend a few minutes on discussing them or raising them. Otherwise, I would like to thank again. Well, if this is not the case, I guess we still have one more final slide. Stay tuned with the Planets project, and you know that there is this resource, and we are sharing with the community all our teaching materials. Thanks for being here today with us. Have a nice continuation of this Friday, hopefully then a nice weekend.